So, we have talked about what climate change really is and why it happens. And so now we're going to look at how do we know it's actually happening. So, just the evidence that we have to back up the claims of climate change and why most scientists and the scientific community in general agree that climate change is in fact real. And so, we're going to start off with the basic increasing carbon dioxide levels. So, Mauna Loa Observatory is this famous station in Hawaii that has been recording carbon dioxide levels since before 1960. And so, here is a full record all the way to November of 2018, the beginning of November. And you can see that obviously the trend is that the levels of carbon dioxide are fully increasing. Um, and so we have actually reached a high of 406.68 parts per million, whereas down here in 1960, we're about at 315 parts per million. So it's quite a bit more carbon dioxide in the atmosphere than was previously. And then just to kind of backtrack on carbon dioxide levels in the atmosphere, we do have this undulation or this, zigzag pattern. And so carbon dioxide levels are highest when photosynthesis is not happening as much. And so in the northern hemisphere, we have the majority of landmass. And so during our winter and going into spring, photosynthesis is not occurring as much, and so my carbon dioxide levels will be higher. Whereas in the late spring, summer, going into fall, my leaves are on the trees going through photosynthesis and thus decreasing the carbon dioxide levels in the atmosphere. So I have kind of this breathing in and out of the earth. And so I do have this seasonal change of increase and decrease of carbon dioxide, but overall, my carbon dioxide concentrations are increasing over time. And those carbon dioxide levels are increasing due to emissions. So if we look at the emissions among the countries, they vary depending on the country. So the developing world has the highest production of carbon dioxide emissions, especially if I look at it per capita. So, here I have total emissions, and here I have per capita emissions. And my per capita emissions here in the United States is the highest. And so we are in the developing world, followed by Australia, Canada, the Netherlands. So looking at per person emissions, our emissions are very high. But these developing nations like China and India are changing quite rapidly. And now you have China being the highest emitter of carbon dioxide. Notice it's not per capita because there are a lot fewer people per amount of carbon dioxide emitted, or actually vice versa. You get the gist, right? But China is the largest emitter of total carbon dioxide emissions. And so as countries increased their industrialization, their use of fossil fuels also increases, thereby increasing their carbon dioxide emissions. And so that's current carbon dioxide concentrations. But what about in the past? How do we know that things have changed from geologic time? And so in the really, really cold areas of the world, like in the Antarctic and in the Himalayas, all that snowfall actually compacts over time and then traps air bubbles in the ice that it forms. And so this gives us a snapshot of history and what the atmosphere looked like in the past. And so we can see that by the layers that are in the ice. And so the layers that are on the top, towards the top of the ice, are younger than the layers towards the bottom of the ice. And this is the law of superposition. And we will see that again very shortly. And so we have this picture of what the atmosphere looked like, whether it be in carbon dioxide or methane, nitrous oxide, so these greenhouse gases. And overall, these greenhouse gases have increased from 400,000 years ago. And so this is where we were. We had a decrease and an increase, and we have these, periods of increases and decreases. But now, if you look at our current level, we're actually way above. Actually, this isn't even more current right now. Our levels are even higher past this 400 mark. And so we can see that we are at historic highs of these greenhouse gases. Another thing is that we can also look at temperature a little bit, in that the oxygen isotopes that are captured in the ice, depending on which ones are present, can tell us a little bit about the temperature of the atmosphere. And so we have light oxygen, or oxygen 16, and that forms when we have cooler temperatures, whereas oxygen 18, or heavy oxygen, forms and gets captured more when we have warmer temperatures. And moving forward into global temperatures, using these historic markers, we can see that our global temperatures have increased 1 degree Celsius since 1880, and even beyond that, we can actually see as well. But 1 degree Celsius doesn't seem like a lot, but the thing is that that's a global change. So that global temperature is not evenly distributed. Things are actually cooler in Antarctica. There's no change in other regions, or in the extreme northern latitudes, we're actually experiencing massive increases in temperature, and this is causing our polar ice caps to melt. And so if we're talking about land ice, glaciers, then we are looking at sea level rise, and even just the melting in general of sea ice and land ice. We have an influx of fresh water coming into the ocean, which ultimately can change our oceanic currents, thus changing our climate patterns all over the world. So this has some serious implications, and we're looking at an even higher increase in temperature. And so here's a really beautiful video from NASA looking at historic temperatures to the present day. And just to get a little snapshot of it right now, I'll show you. But I suggest going to the link in our link document. If you want to see the whole video, you can see it's cool, and it's getting warmer and warmer, as you can see up here at the poles, or at the North Pole, warmer and warmer. And if I just fast forward a little more, this is where we are, in more present day, a lot warmer than where we were previously. And so that is a really beautiful video that you can watch in full on your own, but you can see there has been a massive change in global temperature. And moving forward, another way that we can look at temperature in the past is through the species composition of these organisms called foraminifera. And these are tiny marine organisms, and different species tolerate different temperatures. And so seeing what species of these foraminifera are present and which are not, we can kind of infer the temperature. And the beauty of them is that they have these tiny little hard shells that actually don't decay, or they resist decay. So we have a lot of space there. We have a lot of things to look at there. And so we can look at a buildup over time. Again, the higher up we are, the younger we are, and looking at the temperature over time, we are able to see that temperatures have risen. And so here we see, if we put carbon dioxide and temperature together, we have an increase and decrease together, as carbon dioxide